So of course all our log and exponential models work really well on growth and decay. And one example would be rate of change, which would be dy dt, because that would be with respect to time, is proportional, so we have some constant of proportionality to y, would look like this. So I just took all these words and turned it into an algebraic expression. And that would actually model either growth or decay. And so if I take this and I decide, oh, you know what, I would like to integrate this, which means I'll need to get the variables on the same side. So let's see, if I multiply by dt, I'll have a dt over here, and if I divide by y, I'll have a y over here. And then I can integrate. Now remember, k is nothing more than a constant. It's some number. And on the left-hand side, I'm going to have natural log of absolute value of y. And on the right-hand side, I'll have kt. So think of this. If you had 2 and dt, you'd get 2t. If you had 5 and dt, you'd get 5t. So when I erase this or think of it as k, then I get kt, because k is just a number, a constant. And then of course I have to put my plus c somewhere. I like to put it over here. And then I'd like to get y by itself. So in order to make that happen, I will power both sides up. And when I do, on the left-hand side, I'm just going to get y. And on the right-hand side, I have e. And that's now all my exponent. And remember, I could split that. So e to the kt plus, times e to the c. Remember, that's using this rule of x squared times x to the 7th equals x to the 2 plus 7. And so going backwards, I can split, right? But it'll be multiplication. So if I have a sum, I can split and it'll become a multiplication. And now keep in mind, this is just a constant. So we're going to call that still c. So I get c e to the kt. And I bet you remember seeing this formula because it looks remotely similar to this one, which everybody remembers. And this is, in fact, my exponential growth and decay model, which is the same as PERT. And just as a couple of reminders, so when I'm looking at that formula, C is an initial value, just like in PERT. P is your initial value, and K is either the growth constant, if it's positive, or it would be a decay if it's negative. And one of the formulas that we're going to use fairly often, and you will see definitely on the AP test, is Newton's law of cooling, which has that embedded in it. And for each of these variables, this is what they represent. So the object's temperature would be here, and the temperature of the surrounding medium, so the air might be an example, and then the little t at the top represents time.